Hi everyone, welcome to Pristine AI. In this video, we are going to talk about Dataproc Serverless. I am assuming that you have already watched my previous video on Dataproc. If not, I have added a link in the description. Please go ahead to know more about Dataproc clusters. So let's get started. As we all know that Dataproc is the go-to service in GCP if you want to run your Spark workload. In the earlier days, when people were migrating from on-premise Hadoop systems to GCP, they were using Dataproc to migrate their workload from on-premise Hadoop to GCP. Majorly, Dataproc has been used for running these Spark workloads. To execute any Spark job, you have to create a Dataproc cluster. Then you have to decide the number of resources that would be required by your Spark job. To get the appropriate number of resources, you have to run your applications multiple times with the multiple combinations to get the right resource. This particular thing was actually an overhead for the data engineer to deploy the jobs on the clusters. To overcome this issue, GCP has provided a new service called Dataproc Serverless. In the Dataproc Serverless, you just have to focus more on the application instead of the deployment. So the main advantage of Dataproc Serverless is that it provides the resources. You don't have to provision them. You just have to deploy your application on Dataproc Serverless. As and when the resources are required, Dataproc Serverless will auto scale to those resources. And when your job is completed, those resources will get shut down by the Dataproc Serverless. There are two ways to run Dataproc Serverless workload. First one is using Spark batch, in which you can call the batch APIs of Dataproc Serverless. This particular API will submit your job into Dataproc. A Dataproc Serverless will execute those jobs. It will create the cluster for you. It will execute your job. Once the job is completed, finally the cluster will get shut down. Other ways, Spark Interactive. If suppose I want to do some interactive data analytics, I can open the Jupyter Lab. In the Jupyter Lab, I can connect to the cluster. Once the analysis is completed, the server gets shut down. So when we compare Dataproc Serverless with the Dataproc on Compute Engine, we can see that there are multiple capabilities that Dataproc Serverless provides, which is not available on the Dataproc on Compute Engine. First one is the processing framework. In the batch, Spark supports Spark 3.4 and earlier versions. In the interactive mode, we have the Pyspark kernel for Spark 3.4. While on the Dataproc on Compute Engine, we have other frameworks like Hive, Flink, Trino, and Kafka. So even if I want to just use Spark, there would be already existing services in the Dataproc on Compute Engine, which will get installed. One of the best advantage of Dataproc Serverless is the startup time. It takes around 60 seconds to start the cluster, but on the Dataproc on Compute Engine, it takes more than 90 seconds. Resource management in Dataproc on Serverless is Spark based, and on the Dataproc on Compute Engine, it is Yarn based, meaning that whenever we want an additional resources, Spark based cluster will use the properties available in Spark like dynamic allocation to increase the number of resources. Dataproc Serverless supports Pyspark, Spark SQL, Spark R, as well as Spark Java or Scala. So let's go ahead and look into the Dataproc cluster. To run the Dataproc Serverless, you have to first open the Dataproc service. In the Dataproc service, there are multiple sections available. The first section is for the cluster mode, where you can create new clusters, and in that cluster, you can submit your Spark jobs. The other mode is the serverless. In the serverless mode, there are three options available. First one is the batches, and the second one is the interactive. And there are also some interactive templates available. We would be focusing more on the batches. So whenever you want to create a new serverless Spark job, you have to use this API. You can go to create. Once you click on the create, there would be multiple options that would come up. So you can pass on what is the batch type. So if it is a Pyspark job, you have to click on Pyspark. Runtime version, if you want to use Spark 3.4, you can use that. Or there are other versions available as well, like Spark 3.3. If it is a Pyspark job, you have to pass on the Python file name. If there are additional Python file that is used by your application, you can pass on here. Once you click on the submit button, your Spark job will get started. After the Spark job is completed, the cluster will get shut down. Now, this is one way of creating the Spark job, but generally when you are working on the production, you won't be coming to console and creating the job manually. So the other way is using the APIs. So you can use the Dataproc Serverless API to submit your Spark job. So there is an application that I have built for this purpose. This application is going to read the data from Google Cloud Storage as well as BigQuery, do some transformation, and finally write it to another table in BigQuery. So there are three main components. First one is the extract component, which will read the data from BigQuery or GCS based on the configuration. There is a transform component, which is responsible for doing the transformations on the dataset that has been loaded. And then finally, the load component, where we are going to provide the configurations, whether we have to write our data into GCS bucket in CSV format or Parquet format, or if you want to write to a BigQuery table, you can pass on those parameters. The dataset that we are going to deal with is the movies dataset. In the movies dataset, you can see there are multiple columns like movie ID, title, and genre. Similarly, there is a rating dataset. In the rating dataset, again, there are multiple columns like user ID, movie ID, rating, and timestamp. This dataset is available in the Google Cloud Storage in the raw format. So the application that we have currently built, it will first read the data from Google Cloud Storage or from the BigQuery table based on how you have configured the reading the data from raw sources. Once we have read the data from raw sources, we are going to apply some transformations like, column management or removing a few columns or adding a few columns, applying few filters. And finally, the output would be written into BigQuery table. So if you look into the application, we are passing two arguments. First one is the app name. This app name will be the app name for our Spark application. So the job that you are going to submit, it will be assigned an app name. And this app name is something that we provide. If we don't provide it, it will write a default app name. Other argument is the layer. So based on how you want to process the data or at which stage you want to process the data, there is a layer concept of layer that we have added in the script. So let's say I want to write my data from raw folder to the refined, or from the raw table to the refined table in BigQuery. You have to pass on raw to refined. Similarly, if you want to do some transformation, use some joins like joining two tables, then and finally writing to the BigQuery table, we are going to use the layer called as refined to integrated. Integrated meaning that you are going to integrate multiple tables join by using join operations and finally writing to the BigQuery. Let's say if you want to invoke a raw to refine workload, then the configuration for the raw to define will get picked up. So if you see, there is a config called r2rconf, which means that we are going to read from raw table or raw location and write it to the refined tables. So there are two data sets, a movies data set, which is configured to read from a Google Cloud storage, and then output should be in the refined data set in the BigQuery table, and the rating data set, which is going to read from BigQuery only and finally writing to the refined layer in the refined data set in the ratings table. Now, when we call the transform function, in transform function, you can see that there are two conditions. If it is configured for raw to refined, it will go to raw to refined function, and this function, based on the configurations, it will read the data. It is going to apply filter on the genres. So let's say if I want to store only adventure related movies, then you can filter only the movies which contains adventure in the genre, and then we can drop the genre column as well. Similarly, for the ratings dataset, I only want to store those ratings which is more than or equal to 3.0. And also I want to rename some column called as timestamp to TS. So this is how raw to refined flow will work. On the refined to integrated flow, I want to join these tables. These tables will come from the refined dataset, and we are going to join it on the basis of movie ID. And finally, we are going to select a few columns and write it to the integrated dataset in the BigQuery table. Once we have written the Python script, we can push this script in the Google Cloud Storage. So there is a bucket called GS code. I am going to keep all the code in this particular bucket. If you see, I have already uploaded the main.py, which contains the code for running the Spark job. There is a lib folder as well. So if you want to connect to BigQuery using Dataproc, you have to provide a connector. So Dataproc Serverless expects that all the connectors are available in GCS, and you can pass it as a configuration parameter. The data is available in another bucket in the GCS called as GS raw. You can see that there are two tables already available. The first table is movies, and the second data set is ratings. So I have already created a raw data set inside which I have movies and rating tables. These tables point to the GCS storage. So let's say if I want to query raw.movies, I'll just run it, and it will show me the data that is available in GCS. So this is an external table created on the GCS location. Similarly, I have created table for refined dataset as well. So all the filtered and clean data will be residing in the refined dataset. And there is third dataset called integrated. Whenever you want to do some transformation and integrate multiple tables, the output will be stored in the integrated layer of BigQuery. So if you can see, there is a movie ratings table available in the integrated layer. Now, let's say I want to invoke these jobs. So how I can do that? So Dataproc provides you the Dataproc APIs, which you can call maybe using a Cloud Shell, or if you want to call it via some scheduler like Cloud Scheduler or Composer, that is also an option. So for our demonstration, we are going to use Cloud Shell. We are going to do a curl request to the Dataproc API. We'll pass on the configurations. We expect that whenever we do a curl request, it will submit a Spark job in the Dataproc serverless. Let's talk about the parameters that we have to pass to Dataproc APIs. There is a Pyspark batch. Since it is a Pyspark job, we have configured it for the Pyspark. So you have to pass on multiple Pyspark parameters, like what is the Python file URL. So since it is in GCS location, we have given the path for GCS. Arguments that we have to pass, we have already provided app name, which is raw to defined app, and the layer is raw to defined. Similarly, for connecting to BigQuery, we have passed the Spark BigQuery connector. On the refined to integrated layer, you can see the similar configuration, that if you want to connect to the code, since we have the code available in the same Python script, I have provided the same location for Python file, which is in the GCS. And the argument now have refined to integrated for app name as well as layer. it is refined to integrated. The curl command looks like this. It says that if you want to trigger, you have to pass the request .json and the API, which is provided by Dataproc Serverless is this. So you have to pass on the Dataproc googleapis.com/v1/project and then the project ID, location. And since we are calling the batch API, you have to pass on the batches. So now I have already created request.json here. If you see, there is an R2R request.json, which has the same information. Now let's invoke a raw to refine layer job. So if you see, we have configured the curl command and we are going to just invoke this, and we expect that the job will get submitted. And once the job is submitted, in some time, we will see that the job is finished. Once you call this curl command, it will provide you a response with the information about the job that is submitted. So you can see it has given the batch ID, create time, operation type, labels, etc. And let's say if I want to check whether the job is submitted or not, I'll just perform a reload. And I expect that there would be one more job that is in the pending state, since the cluster provisioning is being done by Dataproc API. And once that is done, our job will get executed. If you want to see the details of the job, you can click on the batch ID. In the batch ID, if you can see, there are two options. One is monitoring, which will provide you the details of Spark executors. If you want to see for a longer interval, you can select on 1 hour, 6 hour, 1 day, 7 day, as per your requirement. Similarly, on the details tab, you can see the start time, elapsed time, then you can see the creator, the region, batch type is Pyspark, like we have mentioned in the request.json, and all other parameters. Like at the start, it starts with 2 executors and 4 driver cores and 4 executor cores. And the dynamic allocation ratio is 0.3. So it will take a couple of minutes to complete. I'll pause my video till the time. And once it is completed, we can resume. As you can see, the job is now succeeded. You can also see the log of the job over here. It will give you all the logs that you have printed, as well as the logs that has been provided by Dataproc. Now let's see the data that is now loaded using this particular job. So if I go to BigQuery and I go to refine dataset, I expect that we have the dataset available. So let's see. Yeah, you can see that there is a movie ID column and title column. Since we have dropped the genre column from the dataset, we only have these two columns that is now available in the refined dataset in the movies table. Similarly, we can see the ratings dataset as well. You can see there is a user ID column, movie ID column, ratings, which is greater than or equal to 3, and the timestamp column, which is now renamed to TS. Now let's invoke the other job, which will write the data to the integrated layer after joining the tables from the refined layer. I have already created a refined to integrated request JSON here. And once we submit this job, you can see that in some time, once the job is succeeded, the data is now loaded into integrated table. So this will again take a couple of minutes. I'll pause my video until the job is completed. Refined to integrated job is also completed. So let's go to the BigQuery and query the movie ratings table that is present in integrated layer. We can now see that the data is already present. So there is a user ID column, movie ID column, title, and rating. So based on whatever we have configured in our Pyspark job, Dataproc API execute those code and finally populates the target. So this is how Dataproc Serverless API works. Thank you for watching this video. Please stay tuned for more such videos and please like, share and subscribe.